I'm yelling extremely loudly.
Studio quality large diaphragm condenser microphone. They're maybe a little bit hard to make.
Homemade ribbon microphone, homemade dynamic microphone, and homemade condenser microphone. In pursuit of the world's worst microphone here, we're going to just take maybe 20 millimeters of round magnet, and then we're going to tape them into a sort of log or rod. This is going to act as our winding jig and our sort of final magnet, final structure, everything at once. So we've got a magnetic log. This now needs a bunch of wraps of copper wire in order to be an electromagnet. By a lot, I mean like thousands or at least hundreds, and I don't want to do that by hand, so I'm actually going to get a winding jig whipped up here real quick. See if we can't wind this thing. All right, cool. Looks like that wrapping was pretty successful. We'll go ahead and trim this. Here it's looking a little closer up. I think it looks not terrible considering what it is. We'll see if we've super glued it to the drill. Looks like we haven't, which is good. We'll see if we've super glued it to our fingers a little bit. That's medium. Here's our finished winding log. Trim off this excess tape. These are the kinds of things where you leave the winding jig in place so that when you accidentally slice your magnet wire off, you can rewind a new one. The difficult part is we need to hold this coil of wire and this razor blade a little bit close to each other so that this can move back and forth in front of the coil. And that moving back and forth is what's going to make our signal. I'm going to take our previous trash can. I'm going to glue this coil to the inside about there. And that way this indent can act as a place for this razor blade to go. So I'm going to use something called a step drill and just put some big holes behind it to hopefully let a lot of the sound through. Oh, while we're at it, let's go ahead and give our connector a way to connect. Nice. We've got our bad case made. Glue our coil into here. The audio signal goes between pins 2 and 3. Let's go ahead and see if we can solder this delicate magnet wire to this connector. Alrighty, we got the meter out. Let's double check if pins 2 to 3 have any electrical connection between them. Alright, just like that, about 120 ohms. Life looks good. Nice. Alright. Well, with that done, the next step is pretty simply add the razor blade and see if audio comes out. Boom. Okay, there we go. That's looking like a microphone to me. I think that this might be the worst microphone in the world, but we'll test it in just a moment.
Turn the gain way up on the microphone. I think we can get something going here. Here we are, I think, on the world's worst microphone. So when I yell into the razor blade, my sound pressure is actually enough to push it closer and further away from that electromagnet. And when that metallic object, when that specifically magnetic object moves closer to the electromagnet, you get a change in flux through it. A change in flux makes a voltage, and the changing voltage is what the camera will record and play back to you as sound.
The tape-based suspension is not very flexible, which means that the razor blade is prevented from moving both by its high mass and by this tape's sort of very stiff springiness. I'm yelling extremely loudly. We're probably wondering, Could this microphone really be made to sound good just by making the razor blade a lot lighter? This thing is actually just a very complicated, different version of that. And if we get into it, we can see that this capsule really is just that sort of coil of wire with a very light thing that moves when we speak into it. And we are going to see if we can take this lemon zest candle, see if this darn candle will get us through the next step of this build. Do paper bag on this one because we want to drill some steel shavings. Next step on this thing is we're going to need an electrical contact, so I'll go ahead, get a little bit of sandpaper and just make a shiny spot through whatever this reflective crust is. So if we have a membrane over top of this, I'm hoping that that cup downward will prevent my membrane from sticking to this. This is going to be our stationary grid part of the microphone, and a little bit of membrane is going to be our moving audio part of this microphone. I'm going to just electrical tape this raised rim down a little bit so that we have a nice insulating rim. So we just got the final step of actually doing the membrane. Here we're going to bring out some foil. Let's see a little bit if we speak at it, see if it sounds like it resonates. Hello, hello? I'm not sure what I expected to learn there. We've added some light from the other side. Look at that. I can't even block the entire light with my arm like I used to. I think I'm going to try and get the red wire vaguely on the front, the black wire vaguely on the back. Finally, always strain relieve your wires so that any yanking doesn't just pull the wires off the back of your part. We're going to need a capacitor here. We need a big resistor in order to get this thing biased. 1 mega ohm and something like 0.47 microfarads. Alright, I think time to cook a little bit here. I didn't actually draw out the circuit diagram on a sheet of paper yet, so I'm just going off the hazy mental image I have of what goes where. If I remember right, pin 1 is like a ground in these microphones, and then 2 and 3 are your signal and phantom power. We're going to go all unbalanced and all kinds of crazy on this thing. So we're going to go, I guess, maybe 3 to the resistor to the top of this thing. That floating node is going to get capacitored into 2, and then I guess the bottom of this going to go on ground. You know what? If that's incorrect, it'll become obvious quickly. Alright, and hopefully, just like that, hopefully we have our finished microphone. I'm just going to plug it in and see if it works here. Hello? Hello? Does the microphone work?
Alrighty, well there you have it. We have just very quickly made a studio quality large diaphragm condenser microphone.
This is a really pretty expensive connector, so I'm actually going to solder this back off so that I can use this connector in a potential future application. Alright, well there you have it. In the apartment in a day or two, we've actually reinvented the 2 main types of microphone. We got the dynamic microphone on the right, we got the condenser microphone on the left, and this is pretty much every good microphone you'll run into in this world. In order to make the final type of microphone, we're going to need this fancy plastic box. What we're going to do is we're going to hang an aluminum foil piece in this narrow gap, and we're going to glue magnets on either side, And the foil wiggling between the magnets is hopefully going to make a really nice microphone. So we need some long ways holes for the sound to go through. We're going to hang some foil in this direction, and so we need holes on that axis to let the foil through. And then these walls need to stay solid for the magnets to glue down. This is the part where I just get a bunch of magnets like stuck to my hand and stuck to my table. And all right, let's just get the magnet disaster over with here. Now, very annoyingly, it's going to be important that every magnet is magnetically facing the same direction. All right, amazing. I think we actually have a row of magnets on here. And with any luck, they'll all stay glued down. And with any additional luck, they'll all be pointed the same direction. I'll do a quick force check just to make sure that they all pull the same direction against the reference. All right, it's good. First one's good. Now we just got to do it again on the inside. All right, again from the top. If you stop and think too long, eventually you just stop doing the project. So you got to just plow ahead, try and glue the discs to the plastic, and hope for the best. Let's see. Alrighty, our rows of magnets are glued on, which is very, very nice. So this outer and inner row of magnets are going to go ahead and make a magnetic field sort of through that little gap. And then in that sort of through magnetic field, we're going to hang a thin ribbon. And when that ribbon vibrates through the magnetic field, it's going to induce electrical flow. And that electrical flow is hopefully going to get picked up by the recording equipment. Well, finally, let's try and make the ribbon here. Still don't know if folding the ribbon did anything, but I'm still going to use it because it's still the right size. I'm just going to put it through, fold it over, tape it down, and then we'll just tape some wires to it. All right, and there you have it. We've got a little thin piece of aluminum foil hanging between these magnets. On this microphone, it should just go between the signal pins. Let's see here. Just in case that wireless dongle is holding us back at all, I'm going to give it one last try on the cable and see if that does any better.
Turning up the gain a little bit, straight on the cable. Still doesn't seem to do much better, so I guess I'm just going to go ahead and call good microphones are maybe a little bit hard to make.
All right, and there you have it. Homemade ribbon microphone, homemade dynamic microphone, and homemade condenser microphone. Couple of bucks each and a lot of educational fun.